The next two lectures that we're going to look at are entitled Arrays and Strings. This one that we're going to look at today is all about arrays, and the next one is going to be all about strings. So, formal definition of an array is an ordered collection of a number of elements of the same type. Okay, and if we to sort of visualize an array, basically what you've got is a series of memory locations which could be visualized as boxes, and each of those boxes can store a piece of data which is exactly the same data type. So in an integer array, all you can store are integers. In a character array, all you can store are single characters in each box. A lot of students find the concept of arrays quite difficult to get, mainly because in languages like Java and C++ and C#, these concepts are conceptual. You effectively have to imagine them. Your only real alternative is to get a piece of paper and draw them out by hand if you have difficulty with conceptual elements. But all you really need to be aware of in terms of arrays is that it's like having a load of cardboard boxes sellotaped together in a row, and inside each of the elements of an array, or each of those boxes, is a value equivalent to the data type that's being stored in there. When you have an array, you access each of the array elements by the array name itself, and then either the subscript of the array or the index of the array. A lot of the time you can sort of imagine each of the individual elements of an array as the sort of addresses, as if they're a row of houses on a street or something like that. The only weird thing about array indexes is that they're not numbered, for example, 1, 2, 3, 4, 5. They're arranged from a zero numbering system. So the first element of an array is 0. So it'll be 0, 1, 2, 3, 4, and so on. So if you've got an array with 10 elements in it, they'll go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Each of those addresses points to a single array element. So as it says at the bottom there, we could say something like array element 2 contains the value of 78, which is what we've got demonstrated here. And as you can see, we've visualized arrays. Here's an array of integers at the top. Here are the subscripts, or the addresses, or the indexes, whatever you want to call them. At index 0 you've got 45, at 3 you've got 34, and at 5 you've got 55. Like in this one, you've got an array of characters, where at 1 you've got the letter E, and at 3 you've got the letter O. Now, declaring arrays in Java can be local or standard instance variables, like we've done with everything else in the past. We need to make sure that we declare them so that we indicate that it's an array, and we have to indicate what data type it's actually storing. So we've got an example here. This is an integer declaration. The name of the array is mStudentMarks, and the only indicator that we've got that it is an array is that we use the 2 square brackets. At this stage, all we've done is declare it. We haven't created it, but we're just making the Java compiler aware that we want to use an array, and this is what we're going to call it. Later on in the code, we actually do create the array, and what we tend to do is we then create the array itself within the constructor. So we declare the array in the variables bit at the top, and then we create the array in the constructor. So what we've got is the additional section. You can see it in this piece of code here, that mStudentMarks, which we previously declared as an integer array, is a new integer array with 10 elements in it. Okay, and that means we've got 10 empty elements which will only store integers. Now just remember, and lots of students fall foul of this, when you declare an array, for example, with 10 in it, like you can see in front of you there, the array indexes go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not 1 through 10. It's important that you remember that, because we have a lot of students who generate something called an index out of range error, where they've declared, for example, a 10 element array, then they try and access element 10 and it doesn't exist, because you've got to remember that arrays are indexed from 0 through to 9. So if we visualize what we've created, this top part is what we would generally put in our variable declaration. This bit where we've actually set it up as empty with 5 elements in it would generally go in the constructor, and then we would conceptualize that array with a series of boxes, all labelled mStudentMarks, but each one has an individual index of 0, 1, 2, 3 and 4. So if we want to put numbers in the array, we could do it like you see here. And if you treat each individual element of an array as almost like a variable, what we're doing is we're creating 5 individual variables. They've all got the same name, but they've all got different addresses, and you can treat them like variables. So put 13 into mStudentMarks at position 0, put 9 at position 1, 15 at position 2, 7 at 3 and 12 at 4, and there are your 5 values in your 5 indexes of the array. How we can output those? Well, if we can add values like variables, then we can sort of output array indexes or array elements like variables. So we'll put some examples. For example, we can use user.message and output the first element at mStudentMarks 0. We could output the last element at position 4 using a string, and then using a plus concatenator with mStudentMarks 4. Or, as you're going to see a little bit later on, we can even replace the number with a variable. In this case we say mStudentMarks at position index. In the opposite hand to that, we can access those elements just like any other use of a variable. So we can assign another variable to the value that's in the array. So whatever is in position or index 2, stick it in best mark. We could set the second or array index 2, it's not the second one, it's the third one, put the value of 15 in that position. We could assign the value of a variable into an array, or we can assign a variable into an array using a variable as the index. So they are quite flexible in the way that they're used. A lot of the time when we're using arrays and we know how big the array is going to be throughout the whole program, there's nothing wrong with using constants. There's certainly nothing wrong with everything that we've done so far to set it up as an integer array with 5 elements in it, 0, 1, 2, 3, 4, perfectly fine. You can as well declare a constant. So in this case I've got a final integer called num_students, and we've set that to 5, and I can use that value to set up the size of the array. Useful if you've got multiple arrays and you want to set them up all the same size, because you can just use the constant. Another thing that we can do as well is a little bit more higher level. If you don't know how big you want the array to be, you could use something like user.inputInt to input an integer and then set the size of the array in the program to that value. So for example, if I typed in 20, it would set up a 20 element array using the value from user.inPoint, and the values or the indexes would go from 0 to 19. So what we're going to do for the rest of the lecture is use a worked example. We're going to use a short program with a small array in it for 5 students, and we're basically going to have a way that we can manage the marks for those students that they've got in a test. So we're going to use the indexes, or the index for the array, as the registration number or the student ID for each student. So we'll have student 0, student 1, student 2, student 3, student 4, and the array will hold the marks for the results of a test. And what we're going to do is we're going to have 2 methods, one which will allow us to enter a mark for a student, one which will allow us to display a mark for a student. And what we're going to do is in each method we're going to use the student number as a parameter in that method. So when you create arrays in BlueJ and then you inspect an object that you create, what you're going to find is that it won't display the content of the array straight away. What you'll find is, as you can see here, in the object inspector you will see the array, but then you get this strange arrow symbol. And what you have to do is if you double click that symbol, it will open an inspector within the first inspector. But what it will allow you to do is actually see the array rather than trying to conceptualize it. And for a lot of students who find conceptualizing arrays difficult, this is actually quite handy for you, because it at least gives you the option to see what's actually going on. So let's have a look at the first program, and we'll have a talk about it. Okay, so I've opened the program called Manage Marks, which I've downloaded from the VLE, and let's just have a quick look at the code before we do a quick run. And as you can see, what we've got is a constant, a number of students, which we've set to 5. I've initially declared the array, we've set it up, and in the constructor I've actually created the array in there with a size of the constant, which is 5. So at this point, just remember that our array goes 0, 1, 2, 3 and 4. In terms of methods, we've actually got an enterMark method. Now enterMark at this particular point has got 2 parameters. Everything we've seen so far has only had 1 parameter, so it's a little bit new, but it's not that much more difficult. In the end, what we've got is a method called enterMark, and it will ask for a student number, which is the index of the array or the position in the array, and the student mark, which is how much they got in the test. And what we'll do is we'll use that student mark and we will put it in the array called mStudentMarks at the array position p student number. So that will put the value into the array. In the displayMark method, we've got another parameter which is asking for a student number, which again is the index to the array, so it'll be any number between 0 and 4. And then we use user.message to say the mark for student at position student number is, and it will output the value at that particular array index. Now hopefully we'll be able to run this and use it through the object inspector so that we can actually see what's actually happening. But we'll give it a compile and we'll create an instance and we'll inspect. Now straight away we'll have the object inspector, and then I'm going to double click it and inspect the array, and then I'm going to call up the enterMark method, and it's asking for the 2 values. The first one is the student number, so I'm going to enter the mark for student 0 and give them a mark of 55%. Now, when I click OK, it should put that value into the array for us, which it has done. So what I might do is I'll put the details for student 4, and student number 4 got 75%. And as you can see, the values that have actually been put into the array, which doesn't actually happen in a lot of programming languages. It sort of leaves you to your own device to try and imagine what's exactly going on. This is one of the beauties of using BlueJ as a development environment. So we'll call up the display mark, and it's asking us for which student number result that we want to look at. So let's have a look at student number 4, and it should come back with the mark, which is 75. And where we've got the user.message, the mark for student 4 is 75. If I call up a display mark for a student that's not had a mark put in, put student 2 in there, it says the mark for student 2 is 0, which it is. Let's just consider that instead of outputting one set of results for one student at a time, what if we wanted to output the entire array? It's perfectly feasible. Could be, you know, someone says, show me a list of all the results for all the students in that class. From what we know so far, there's absolutely nothing wrong with doing it this way. We just have 5 consecutive user.message statements which would output the value of student 0, 1, 2, 3 and 4. That's okay as long as you've only got a few students. If you had 30 students in a class, or 50 or 100, then obviously there's no way you would realistically write 100 lines of code outputting each of the values in each of the indexes. So there must be a better way of doing it, and it's to use something called a for loop. Now again, if you've done previous programming before, you shouldn't really have much of an issue. The only thing about for loops in Java is you just need to know how they're actually used. And there's 3 parts to the for loop structure at the beginning. Now in some languages like VB, you might have said something like for count equals 0 to 4, which is pretty straightforward. Not so in Java, and it's actually the same in other languages like PHP and C++ and C#. As you can see, in the for loop, there are actually 3 parts to it. You've got the bit at the beginning, and this bit is your start condition. The second bit is your continue condition, and this bit is your increment. So in the first part, this is your start point. So what we've got is an integer variable called index, and it's only going to be used inside this for loop. So what we're saying is for index equals 0. So as soon as we start this loop, the first element or the first value for the index variable will be 0. The second part is a little bit more complex. What we're actually saying is, and I'll try and tell students lots of different ways of doing this, but this is the condition which the loop will continue to run as long as that condition is true. Some students prefer it in the form of keep going as long as that condition is true, in which case, as long as the value of index is less than the value of the constant num_stu. Now in the example we're looking at for this, it's 5. So as long as index is less than 5, keep going. This tells the loop that once we've got through it once, how do we actually deal with index? How do we manipulate it? And all we're doing is saying add 1. So we start at 0, we keep going as long as index is less than the value of number of students, which we know from what we've seen before is 5, and the value of index goes up by 1. So if you imagine how this is working, okay, the first time it goes through, let's use I for index. Index is 0, and index, which is 0 at this point in time, is less than 5. So we say let user.message spit out student 0 and then a colon and then the value of mStudent marks at position 0. So index first time through has a value of 0. We go round, we come back to the beginning of the loop. Index was already at a value of 0, so the index plus plus changes the value of index to 1, and index at this particular point is now worth 1, and 1 is still less than 5. So we say user.message student 1 and the value of mStudent marks at position 1. We go around and we increment again, so the value of index changes to 2 because we add 1 onto it. 2 is less than 5, so we say student 2 and the value of the array at position 2. We go around again, we add 1 on, 3, and we output student 3 colon the value of the array at position 3. We add 1 on again, 4 is less than 5, so we say student 4 and the value of the array at position 4. We then go back again around the loop and we add 1 on, and this time it has a value of 5. Now the thing is that 5, which is the current value, is not less than the value of number of students, it's equal to. So that turns from being true to being false. And because of that, we then skip the array, skip the loop, and we jump out. So let's have a look at that in action. Okay, so I've downloaded Manage Marks 2 from the VLE, and I've just opened it up in BlueJ, and I've just opened up the code, and we can have a look at it. This follows on from Manage Marks 1, so you see a lot of similarities with the first one apart from the new methods. But very quickly, again, same constant for number of students set to 5. We've set up initially the integer array for student marks. We've initialized the array, so we've created it empty for 5 students. We've still got the enter mark method, which we use for putting values in. We've still got the display mark for displaying the results for a single student, and then we've got our new method at the bottom for displaying all the marks. We have a local variable called index, and in the loop, just like in the example, we start at 0, we keep going as long as the value of index is less than 5, and we go up in ones. And every time we go around the loop, we say the mark for student at the value of index is the value of the array at position index. So what we need to do is let's fill the array up, and then we can inspect it and see what goes on. So let's create an instance and inspect it, and again we'll need to inspect the array as well. So let's fill the array up first. So I'll do this one at a time. So we'll have student 0 scoring 10. You can see that's changed there. Student 1 scoring 20. Student 2 scoring 30. Student 3 scoring 40. And then student 4 scoring 50. So we've got each of the students with the student IDs and each of the grades that they've got. We can, if we wanted to, just display the mark for one student. So student 4, we know, has a score of 50. But let's go through the whole array using display all marks. And it's literally a loop that will do the same thing 5 times. So 0 is 10, 1 is 20, 2 is 30, 3 is 40, and 4 is 50. We've got a bit of a grip of how arrays can be used for storage. We're now going to start doing something a little bit more structured. And this time what we're going to do, we're actually going to search arrays. And the easiest form of search that we can perform, knowing what we already know, is something called a linear search. What it means is that we search the array from the beginning right through to the end for a particular mark. And what we're going to do is we're going to use a for loop, and we're actually going to try and find which student got the best result. And what we're going to do is we're going to loop through the array, starting at the beginning, going all the way through to the end. And when we've got through to the end, we're actually going to highlight what the highest mark was in the array. So here's the code, and what we've done is, let's try and illustrate this with some annotations. We've got 2 variables which we start at the beginning, one called index, which we use to keep a track of which index in the array we're looking at, and we've got another array another variable called best mark, which is going to store the highest mark that we find. Strangely, this one might be a bit odd, but what we're doing is, before we do what we do in the loop, we actually set the first element of the array to best mark. It seems a bit strange, but what we're actually doing is we don't know what the highest number is. So let's just set the first one being position 0. Let's just make that the highest one, because we haven't looked in any of the others yet, so we may as well set the first one to the highest. It could be that the second one is higher and it will change straight away. It could be that the first one is the highest one, so it doesn't really make any difference. The next bit is our for loop. Now there's 2 structures inside the for loop. We've got the sort of outer for loop that we sort of know about, and then we've got an if statement inside that. So we need to look at this in a little bit more of a structured way. The outer for loop is just like the other one. It goes from 1 rather than 0, which is a bit weird, but basically we've already sort of done the 0 bit with this line here, in that we've set the highest grade at the minute to the first element in the array. So we only really need to start from the second point, which is 1. So it goes from 1 and keeps going as long as the index is less than the highest value of the number of students, which is 5. And we go up in ones. So this loop will go 1, 2, 3, 4. But what we do is we use the value of index to check the current highest mark that's in the array. So if the value in the array at position index, so the first time through it'll be 1, second time through it'll be 2, third time through it'll be 3, last time through it'll be 4. So if the value in the array at that position is greater than the current value of best mark. Now, first time through, best mark is just the first one. If the subsequent value in subsequent array indexes is higher or is greater than best mark, we set best mark equal to the value that's in the array at that point. So we make that the biggest mark. And it will do that through the loop. it will check the current value of the array at that position against the value in best mark. If it's bigger, then we make that the highest mark. So once we've gone through this loop all the way through to the end, the best mark should be the highest mark in the array. So let's have a look at that working. Okay, so I've downloaded the program Manage Marks 3 from the VLE, and I've just given it a quick compile. So let's just have a look at the code. Again, it's a follow on from all the others, so all we really need to be interested in is the new code that's been added onto this. So the constants are the same, the constructor is the same, enter mark is the same, display mark is the same, display all marks is the same. It's just display the highest mark, and it's basically the code that was in the PowerPoint slide represented in here. So I shouldn't really need to explain what's going on there here. It's exactly the same. The only thing is that there are some comments in there for when you want to open this project yourself, and it gives you an idea of what's actually going on. So we can jump straight in to the demonstration. So let's create an instance and inspect it. And again, what we'll do is inspect the array as well, so we can see what's going on. Let's fill the array up with some values, and we'll fill it up in the same way. So again, bear with me while we put some details into this, and we'll do it a bit quicker this time. Like they didn't score very well on this test. All the other elements work, so we can say display all marks, and so we've got, again, just to make sure it works, 0 is 5, 1 is 10, 2 is 15, 3 is 20, and 4 is 25. So all that works. Now obviously, let's have a look at what will happen when we try and run highest mark. It's going to set highest mark to 5 because that's the first one, and then it'll say, right, well, is that one bigger than the current best mark? Which it is. So that'll become the best mark. We have a look at this one. Is that higher than the best mark? Well, yeah, so that'll become the best mark. But look at that one and say, is that bigger than the current best mark? Which it will be. And then it'll look at the last one and go, well, is that one bigger than the highest mark? And obviously that is as well. And it should tell us at the end that that is the highest scorer. So let's display the highest mark, and it should tell us that the highest mark is 25. And if we look at the value in the array, it clearly is. Obviously what you can do is run this yourself and mix the numbers up a little bit so that you can sort of have the highest mark somewhere in the middle and lower marks after it, just to make sure that that still works. Okay, as a little addition to that, and you can have a bit of a play yourself, here's a question for you. At the minute, as you've just seen, all that we get is, when we run the highest mark method, the only output we get is the actual mark that's been obtained for the highest mark. What we don't know is which student scored it. So a question that we can look at this point is, how do we change the program so that it will output the student ID for the student who got the highest mark? The only small hint I'm going to give you is that you will need an additional variable, and I would call that best student or best student ID or something like that. Again, feeling confident, no harm in taking the current Manage Marks 3 and changing it so that the user.message outputs the student ID as well as the mark that they've got. Okay, we'll have a look at that in Manage Marks 4. So, I've downloaded Manage Marks 4 off the VLE, opened it up, and let's just have a look at the code. Again, it's a development from Managemarks 3, so there isn't that much that's actually been done differently in the previous code that we've written. It's just the display highest mark method that we've changed. And the only thing I've done is I've declared a variable called best student, which will hold the array index of the person with the highest mark. And what I've done is where we initially set the highest mark to the first array index, I've set the best student value to the first index as well. So best student 0 has currently got the highest mark. The only other alteration I've made is when we're going through the list comparing each array index's score against the current highest mark, is I've actually set the value of best student to the value of index, which we use to go through the array, when the current value that we're looking at in index is greater than the current highest mark, so that when we compare the two, we set the best mark to the value in the array and the best student to the value of index. Okay, so what we're going to do, and unfortunately you'll have to watch me fill the array again, is we'll actually demonstrate that's working. So we'll create an instance and we'll inspect that along with a look at the array, and I'm going to do it in a bit mixed this time. So I'm going to fill the array up and I'm going to do 5, doesn't exist, 4 with 34, I'm going to do 3 with 21, I'm going to do 2 with 96, I'm going to do 1 with 17, and then position 0, index 0 will score 23. That's about as mixed up as you can get. Now clearly the highest value is at position 2, and we're going to incrementally visit 0, 1, 2, 3 and 4, and hopefully it will tell us the best mark but also the best student, as it'll output the value of index. So again, if we display the highest mark, it will tell us the best student is 2 with a mark of 96. To get the output for that, if I just have a look at the code again in the output editor, because I think I missed it out a little bit, I've actually output the value of best student after the string for best student and the value of best mark for the highest mark. I didn't quite show that, I was a bit caught up in the loop, but I've outputted the value of best student now as well as the best mark in the user.message. Nice. We've looked at arrays, we've looked at how they're declared and how they're created, we've looked at how we use array subscripts or array indexes to access individual elements of an array. One thing I will tell you is you might declare an array with 10 elements, but just remember that those elements start at 0 rather than 1. So on a 10 element array will go from 0 to 9, a 100 element array will go from 0 to 99. Okay? Each element of an array can be treated like a variable. So we can say scores at position 3, temperatures at position 7, and so on and so on. And we've looked at the for loop as a means of accessing the array element by element, a position at a time. We've concentrated on integers array for this particular lecture, but you can create other types of arrays as well. And maybe at some point in the future we'll go beyond that and we'll look at things like 2-dimensional arrays. But for today, let's just worry about single dimension integer array types.